Okay, when we go over reviews, guys, I'm going to go over types of questions that you guys are going to see, but it's not going to be like, okay, there's 10 questions on your quiz, and here's the 10 questions that we're going to go over. It's just an idea of what you could see. There could be questions that look like stuff from WebAssign. There could be stuff with fractions. There could be stuff that was in the notes. It could be on practice problems. So all the stuff that we have talked about over the last few days could possibly be on your quiz on Tuesday, tomorrow. Algebra 2 is Wednesday. So I've already posted this review worked out. It's in modules. You're welcome to pull it up and look at that as we go over it, but ask me questions as we go. There's going to be a little bit of each. It's not like a 25 question quiz. I'm not off the top of my head. There might be 8 or 9 questions. I'm not sure. But you need to be able to do all of the stuff that we've been working on. Anything that we've talked about is fair game, so I need you guys to understand that. There are no calculators tomorrow. You have to be able to multiply numbers and stuff like that. So when we look at something like number 1, slope, distance, and midpoint, that's what we did on the first day. If I'm going to find the slope of these 2 points, okay, the first thing, I like to have them on top of each other. I told you guys that before. But when we're doing the slope, we need to have y's on top and x's on the bottom, correct? So I'm going to say -1 minus 5. Since I start with -1 in my numerator, what am I starting with in the denominator? 12. Okay, so 12 minus 4. You guys with me? So -1 minus 5 is -6. 12 minus 4 is 8. And what would this simplify to? -3/4. Perfect. That's it. There's your slope. Very simple. If you're going to find the distance, remember the distance. It's the x's and the y's. Keep your x's together. So I'm going to write my parentheses here. Make sure I have a squared. Put a minus sign in the middle. And then there's a plus. I have a parenthesis with a squared and a minus sign in the middle. You keep your x's together. You keep your y's together. So it does not matter what order. You could say 4 minus 12 or 12 minus 4. How come the order doesn't matter in this case? Because if it's a negative, when you square it becomes positive. So I'm just going to say 12 minus 4. And then I'm going to say -1 minus 5. What is 12 minus 4? 8. So I have 8 squared. Plus -1 minus 5 is -6 squared, right? So that ends up being 64 plus 36. Which is what? What's 64 plus 36? 100. Do I leave my answer like that? What's my distance? 10, okay? If this was a radical that wasn't a perfect square, but could be simplified, you guys need to do that. Make sure we're simplifying everything. Okay? Now is the time for questions, guys. I'm not answering questions on the quiz.
Are we going to be given the formulas, or we have to?
No, you have to know the formulas. All right, last thing we're going to talk about is the midpoint. Well, what do I do to the x's and the y's? To find the midpoint, what do I do to the x values and the y values? You add them. You're going to take the average. You're going to add and divide by 2. So I'm going to say 4 plus 12 divided by 2. And then 5 plus -1 divided by 2. What's 4 plus 12? Okay, 16 divided by 2 is 8. 5 plus -1, 4. 4 divided by 2 is 2. Notice I put the midpoint as an ordered pair. It's a point. You need to have an x, comma, y, and parentheses.
Are we submitting this anymore?
Questions? All right, you're gonna might have another question that says, hey, here's an equation. Tell me the slope, the y-intercept, and show me a picture. How do you graph a line, guys? What does it have to be in? Y equals mx plus b. Slope, intercept. So do that first. I want it in slope, intercept. So I'm going to add x and subtract 9 to both sides. You guys agree? So 3y equals x minus 9. Now what do I do? I'm going to divide by 3. So y equals, what's the slope here, guys? Not x over 3. What's the slope? 1/3 x minus 3. If you guys tell me where the line says slope and you tell me it's x over 3, I'm marking that wrong. Slope does not have a variable in it. Your slope here is positive 1/3. What's the y-intercept? You can say y-intercept is -3, or you can tell me it's the point 0, -3. Don't just, if there's a line, don't just write -3. Either indicate y-intercept is, or write it as a point. And then how am I going to graph that? Very simple graph, guys. Where is my intercept? Right here at -3. This is a positive line, so draw yourself a little picture, like say, hey, it goes this way. God bless. I'm going to go up 1 and over where? 3. So 1, 2, 3, something like that. Down 1 and over 3. 1, 2, 3, something like that. Boop. We need to remember x equals are what kind of lines and y equals are what kind of lines. X equals is what kind of a line? Vertical, good. Y equals are what kind of lines? Horizontal. Think about where the point is. If it's on the x-axis, the line's going to go through the x-axis. Make sure you pay attention to that. All right, how do you know if lines are parallel, perpendicular, or neither? Well, let's do a little thinking here. The slope. So parallel lines have what? Same slope, good. Perpendicular have two things, not just one. Has to be two. What are the two things? Opposite and reciprocal. That's not even close. Reciprocal. Try again. Reciprocal. Not just one's negative, one's positive. Not just that they're flipped. It has to be both. So how would I determine if these lines are parallel, perpendicular, or neither?
You do like the slope.
We're going to find the slope. Here's line 1. So my slope, I'm going to say -7 minus a -16. So on the bottom, 0 minus 1. Minus a negative is the same as plus. So I end up with what on top? What's on top? 9. So 9 over -1. Okay. So now I'm going to do the same thing here. Here's my x, here's my y. So I'm going to say 11 minus -7 over -1 minus 1. What's 11 minus a -7? Same thing as plus, right? So 18 over -2. What does that simplify to? -9 over 1. Now at this point, guys, these are the two slopes. Are those two things exactly the same? Yes. So these lines are parallel. If you guys don't show any work and you just randomly guess neither and you're right, congratulations, you're not getting any points. You have to show me why. If this were to end up as 9 over 1 and -9 over 1, are those two things parallel? No, that would be neither. They have to be exactly the same or opposite reciprocals, meaning one positive, one negative, and they're flipped of each other. So make sure it's both of those things. You guys with me so far? Everybody all right? Okay. Shooting along. I'm going to do this one. I'm going to do this both ways. I'm going to do parallel and perpendicular. Now, you guys might see a fraction. Don't freak out. You guys all can deal with fractions. But you might be given a line that says, here is a line. Give me something parallel to or perpendicular to. Remind yourself. I'm going to do both. Parallel lines have what? Same slope. Perpendicular is opposite reciprocal, okay? So you have to determine, first of all, what the slope is with the line given. You guys agree with me? It would be 2y equals -6x plus 4. Move the 6x over. And then divide everything by 2. So y equals what? -3x plus 2. Does that plus 2 have anything to do with our problem? No. This is all I need to know. So a line that is parallel to that, I'm going to use the slope -3 over 1. A line that is perpendicular, I'm going to use what? +1 over 3. And now what point am I using? The point that they gave me. In this case, it's 4, 2. Nice, pretty numbers. You can tell this is Mrs. Carver's writing. Miss Thompson, sorry. Thompson. So here's x and here's y. I'm going to use point slope form. I'm going to say y minus, what's the y they gave me? 2. equals negative 3 over 1, x minus 4. There's two things I have to do to get this into slope-intercept. Distribute the slope, and then move the number over. So y minus 2 equals, what's negative 3 times x? Negative 3x. What's negative 3 times negative 4? 12. Perfect. Last thing. Add 2. So y equals negative 3x plus 14. You will not be asked to graph the line that you create. You will have a piecewise where you have to graph, but you don't have to graph one that you write parallel or perpendicular to. All right, now we're going to do the same thing, but we're going to find the perpendicular. Make sure your slope from the one that you found is opposite reciprocal. So y minus 2 equals positive 1/3 x minus 4. Same exact thing. We're going to distribute slope and then move the number over. So I have y minus 2 equals, when I distribute this, I have 1/3 x minus 4/3. Agreed? Hardest part of this problem is this next step because you guys are like, oh, it's a fraction, I can't do it. Yes, you can. We're going to add 2. Put it over 1 so you remember, oh, wait a second, I can't add this until it's a common denominator. What's my common denominator between 3 and 1? 3. Okay, watch what I do here, guys. I'm going to carry this negative sign over here because a lot of times when we do this, we forget that if it's negative, we forget. So just rewrite it so you don't forget it. If I multiply the bottom here by 3 to go from 1 to 3, what you do to the bottom, you do to the top, so this becomes 6. You guys agree? So what's negative 4 plus 6?
2.
So plus 2/3? Yeah? You guys with me? Okay. An arrow means the graph goes on forever and ever and ever. So let's talk about domain. Left to right. Where does my domain start? Negative infinity. Do I have a bracket or a parenthesis? Okay, perfect. You can use all of these values on the x-axis up until what number? 1. Is 1 included at all on either piece of this graph? No. So your domain stops right here at 1. It's not included. Hola. But is that the end of our domain? No, there's still more graph there. Where does the domain pick up again? Where is this second piece? Where does it pick up again? At 1, and it goes to where?
4.
To 4. Does it include 4? Does it include 1? No. If you guys want to put a U here, that's like a math word saying and, you can. But there is a specific gap in this graph where there is a domain value that does not satisfy. It's not satisfied. It does not exist on this graph, and it just happens to be at 1. Do you see how they're on top of each other? There was a WebAssign question where you had one on top of the other, but one of them was solid and one of them wasn't. All that means is where it was solid, the graph did exist, did include that domain value. Where it was open, it didn't. Because you cannot have two repeating x's. We talked about that. You cannot have both. You will never have two closed circles on top of each other. You can have them next to each other, but not on top of each other. So let's talk about the range. I know for some of us this is hard to see, but we're gonna get through it, I promise. What is the range? How do we read range? Bottom to top. So what is the lowest value that exists on this graph? -1. Does it include -1? Yes. Now let's think about this. Some of you are going to say, well, there's a gap. Is there a gap in the range? Okay, look, all of these values on the y-axis are being used on both sides of this, right? So now you're like, well, wait a second, there's a gap on the right, but what do you notice about the y values over here? Are they being used? Yeah, they're still being used. Then it picks up again, and they're still being used, they're still being used, they're still being used, but it stops on the right here, but what does that arrow tell me? That they keep going, right? So actually, guys, what is our range here? -1 to infinity. Perfect. Now again, tomorrow you are more than welcome to use my color pencils. I promise you I made the graph big enough that you guys won't have to be like squinting and all this stuff. You will be able to see things fine, I promise. But there's probably going to be a little bit of it. You got to think a little bit. It's not just going to be like negative infinity, positive infinity. You got to make sure that we're thinking a little bit. All right, so now we're going to talk about increase, decrease, and constant. Increase means the graph is going what direction? Up. Decrease means it's going where? Down. And constant means it's doing what? Staying the same. Is there an interval? Yes, sir.
Isn't there a second set of range?
No.
No, why?
It's every value is being used from -1 up to infinity. You don't look at each piece separately. Is there an area on this graph that is saying constant? No. So right away I'm going to write none or nope or something like that to let me know, hey, I don't have an area of that. So put your finger on your graph and kind of see what's going on. Where is the graph going up and down? What did I tell you is probably a really good thing to do so you don't make any mistakes? Cross off what? Cross off the y. Don't look at the y. We don't read intervals of increase, decrease, and constant on the y. It's only on what axis? The x. So if I start on the left-hand side and I put my pencil down, what is the graph doing? It's going down. It's decreasing from where on the x-axis to where on the x-axis? Perfect. Negative infinity to 0. Always use parentheses. So then what happens? The graph does what? It increases from where?
0 to 1.
It's increasing from 0 to 1. And then what's it doing?
Increasing again.
It's increasing from where?
1 to 4.
1 to 4. Good.
How come you didn't put brackets for?
You don't use brackets for increase, decrease, and constant.
Is it because it's always 1?
Would it technically be wrong if you said it was increasing from 0 to 4? Not really, because you don't have to worry that at that one point is not included in the domain. From 0 to 4, that graph is increasing. So you could say it like that. Either way, it would be fine. I'm going to come back to B in a second. Why is D a super easy one to do? Tell me.
Because it's all on one side of the graph.
It's all on one side of the graph. What else is easy about it?
No gaps.
There's no gaps. What else is there not of? Do you have arrows? There's no infinities. This makes life a lot easier. Domain, from the left-hand side to the right-hand side. What's the domain for this graph?
1 to 7. 0 to 7.
0 to 7, okay? 0 to 7. Does it include 0?
Yes.
Yes. Does it include 7? Good. What is my range? The lowest it goes to the highest it goes.
-1
-1
to
to 3, okay. Include or not?
Yes.
Yep. Increase, decrease, and constant. What can I say right off the bat? No constant. Nope. So remember, we're reading on the x-axis. So cross off the y. We don't care about that. Just on the x-axis. When I look from left to right, what is my graph doing at the beginning? It's decreasing from where to where? Perfect, 0 to 2. Then what is my graph doing? It's increasing from where to where? Draw arrows, it'll tell you exactly. From 2 to 2 to 6, good. And then what's it doing? It's decreasing again. From where to where? 6 to 7. Perfect. If you guys take the time for intervals of increase, decrease, and constant to remind yourself, don't look at the y. The y is not what I'm concerned about right now. And then draw an arrow from where to where is this happening. It'll make your life a little easier. I'm going to say it's going to make it foolproof, but it'll make it easier. All right, so something like this is a little tricky. Something like this is a little tricky. Let's talk about domain, and let's talk about range first. Domain is the x-axis, correct? Yes, guys? Okay, so let's talk about our domain. This is going on forever and ever and ever. So all of this stuff over here is being used, it's being used, it's being used, it's being used, and it stops. But what do you notice about where it stops on the parabola-looking graph? Look just beneath it on the constant part. Do you see how one dot is open and one dot is closed? So what that's saying is, as far as this piece of the graph is concerned, 2 is not part of the domain. But is 2 part of the domain on that piece? Yes, and we read the graph as a whole. So are there any gaps here? Are there any places that x values do not exist? No. It's negative infinity to positive infinity. And again, you can use my color pencils tomorrow. I do not mind. Now we got to think of it, right? You need to turn your paper sideways. Range. We read range how? From bottom to top, okay? Say this is 1. I know this is kind of hard to see. Say this is -1. Where does the range, where do y values begin to exist on this graph? At -1, I agree. Is it anything above -1, like just above it? Okay, but are there numbers in between here on the y-axis? Are there numbers on the y-axis that exist in the yellow? On the y-axis, not on the graph. Are there numbers between -1 and 0? Yes, correct. Are they a part of the green graph? No. So what you guys would see here is the -1 on the y is utilized. Do you guys agree with me? You see that solid green line. So -1 is part of your range. But then it stops. There is a gap, and you can clearly see the gap in what I have highlighted. Where does the range begin again? At 0, and it goes to what? Infinity. Does it include 0? Yes. And we have a bracket on it, a parenthesis on infinity. You can put a U here. The reason that a gap exists here is because it's not that like one part is used on one piece and one part is not on the other. You guys can clearly see that anything between -1 and 0 on the y-axis, none of those values satisfy either piece of the green. So like -1/2, -2/3, negative whatever, -0.00000001 does not exist on either piece of this graph. I understand that can be a little confusing. So if you need to, turn your paper sideways, use a color pencil to draw and say, is there a space that I can color that nothing is being used on the X or Y axis? It's probably the easiest thing to do. As far as intervals of increase, decrease, constant, nothing changes. Does this graph increase? Does this graph decrease? And does it stay constant? Yeah. All right, so from left to right, my graph is decreasing from -infinity to what? Yep, -infinity to 0. And then what does my graph do? It increases from 0 to 2. And then my graph does what? Stays constant from 2 to infinity. Perfect. I think for most of us, that's going to be the hardest part of the quiz. It's a very abstract concept. Ms. Thompson and I understand that. It's just something we got to wrap our heads around. All right, I want to make sure I get to the piecewise. Again, I'm going to do the second one because it's a little more involved. How do we do piecewise? Do I graph everything at one time and try and figure it all out just by looking at it? No. Take your time. Piece by piece. How many pieces of graphs do I have here? 3. I have the first one is y = 0. I have another piece that is, I'm going to say y equals negative x plus 3. And then I'm going to do the last one at the bottom because I'm going to need a table of values. So y equals negative x squared plus 4. Now hopefully from algebra 2, we can remember what each of these things looks like. Y equals 0 is a line. Y equals negative x plus 3 is a line. What is y equals negative x squared plus 4? It's a parabola. Is it a positive one or a negative one? It's negative. It's sad, so it's facing what direction? Down. There you go. All right, so y equals 0. Where is y equals 0? The x-axis. Good. So I'm going to go ahead and draw my line. Again, you're welcome to my color pencils tomorrow. And I'm going to look at my boundaries. Where am I drawing two vertical boundary lines? At negative 5 on the x-axis. 1, 2, 3, 5. And at negative 2. Agreed? Are you guys with me? So what are those boundaries telling me? What part, what piece of that y equals 0 line do I want? The stuff that's in between or the stuff that's on the outside? Stuff that's in between. Okay, so I want to keep everything in here. I know it's hard to see because it's right on the axis, but I'm going to do my best. So I'm going to keep everything that's in here. And I'm going to do what to the stuff on the outside? Erase it. Good. Now we also have to take into consideration what kind of dots we have. Do I have open or closed on what side? So at negative 5, do I have an open dot or a closed dot? It is closed. It is included. Look how big I'm making that dot. If you wanted to go closed. So I see it. That looks like I wrote colored. If you want to say closed with an arrow, so you're like, make sure I know, that's fine. Don't come up to me and be like, can you tell this is it? No. Make sure to write it on your paper. What kind of a dot do I have at negative 2? Open. How do I know this one's open? Because it's not or equals 2, so this one's open. Can you guys clearly see that one is closed and one is open? Okay. All right, so now I'm going to do the red line just because I know it's not in order. It doesn't matter. I'm just going to do the red because it's another line. So my slope is negative 1 over 1, right? And my y-intercept is at 3. I always like to remind myself it's a negative sign, negative line, going downwards, just so I don't make a silly mistake. So I have a point at 3. 1, 2, 3. Negative 1 over 1, so draw your line. And then where's the boundary that I'm going to draw? At where? What do I have circled in red? What number is in that inequality? 2. Okay, so draw a line of 2. Now, some of you are like, oh, that's written backwards. That's fine. Rewrite it backwards. 2 is less than x. Write it the other way. X is what? Greater. Just read it backwards and then you can write it that way. 2 is less than x is the same as saying x is greater than 2. Just read it backwards. So I want all the values on the x-axis that are bigger than 2. So that boundary line, that vertical one I drew, is 2. So I want all the stuff on the right of that line or the left of that line? To the right. This is where all the stuff is bigger than 2. And what do I do with everything else? I'm going to erase it. And the last thing I need to check is, okay, at 2, what kind of a dot should I have? What kind of a dot should I have, guys? Okay, is Ariana the only one here? What kind of a dot should I have at 2? Open. How come it's open? Is there an or equal to sign underneath my inequality? No. So there we go. Here's my open. So you guys can clearly see I have 2 pieces of 2 lines, right? Okay. I'm not going to use black for the next one because it's going to be hard to see. So let's use pink. Yeah.
Why is the x 2 on the red line?
That's what they told us.
Oh,
No worries.
Is there gonna be parabolas
Okay, so this last one, I know it's a negative parabola. I know it's going downwards. How do I know that? Because I just know that. I have a negative sign out in front. Now, guys, you cannot just kind of randomly go in and be like, oh, it's going to go like that. All right, if you have a parabola, which you probably will, you need to make a table of values so you can make sure your parabola is the correct shape and all that good stuff. So, some of you are going to say, well, what number should I use? Well, what are we talking about? Where are they worried about my parabola? In between what two numbers? Negative 2 and 1. So I'm going to go a little bit to the left. So I'm going to say negative 3, negative 2. And then I'm going to say 0, 1, and 2. I'm going a little bit outside just to make sure I get a good picture. But just use whatever the boundary line is. Just go a little bit to either side of it just to make sure. Now pay attention. This is where we're going to make mistakes. This says negative x squared, right? Plus 4. So watch how you write this. Negative 3 squared plus 4. What do we do first? You square the number. So negative 3 squared is 9. So this becomes negative 9 plus 4 is negative 5. So I have negative 2 squared plus 4. What's negative 2 squared? 4. So this becomes negative 4 plus 4 is 0. So now plug in 0. So negative 0 squared plus 4 is 4. Okay. Now I'm going to plug in 1. Square 1 first. 1. Then I times it by the negative. So it's negative 1 plus 4 is 3. Good. And now I have square 2 first. What's 2 squared? 4. So this becomes negative 4 plus 4 is? Okay. So the points that you're going to plot, I'm going to write them over here, is negative 3, negative 5, negative 2, 0, 0, 4, right? 1, 3, and 2, 0. You guys agree with me? From just plugging in? Okay. So negative 3, 1, 2, 1, 2, 3, 4, 5. Negative 2, 0. 0, 4. 1, 2, 3, 4. 1, 3. 1, 1, 2, 3. And then 2, 0. So look at what my parabola looks like. You guys have to get the right shape. You can't just draw like a random U and be like, oh yeah, that's what it is. Now, where do I want the values between where and where? Where's the vertical line I'm going to draw? Negative 2 and positive 1. So between negative 2 and positive 1. It says I want all the stuff that's where? In between or on the outside? Negative 2 is less than or equal to x, less than or equal to 1. So I want everything where? In between those two lines or on the outside? In between. So I'm going to keep the stuff in the middle here. And erase everything else. And the last thing you need to check is what kind of dots you need at the ends. What kind of dot at both ends? Both of them are closed. In this case, guys, does this entire piecewise function connect? Does the whole thing connect? No. No. The pink line stops at 1. Where does the red line start? At 2. It doesn't connect it. Not all the time are all of your piecewise functions going to connect. So it's not the easiest thing in the world for us to grade. But we are going to go through and make sure your notations are correct at the end. The shape of your graph is correct. That if you have a parabola, it's in the right spot. Your lines have to be in the right spot. Like if you don't know where to put something, guys, make a table of values. Make a table of values. All right, so we have gone over anything that you could possibly see. We need to know what zero slope looks like. We need to know what undefined slope looks like. We need to know an x equals line versus a y equals line, all that good stuff. But you guys need to know the formulas, and you're not going to get a calculator. Anybody have any questions? No? Okay, I'm going to upload this so you guys have it.